Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Last lecture we have seen how to find the eigenvalues and eigenvectors for the given matrix. In this lecture we are going to cover Cayley-Hamilton theorem and find the inverse of matrix by using Cayley-Hamilton theorem. Let us see the statement of this Cayley-Hamilton theorem and how to find the inverse of matrix by using Cayley-Hamilton theorem. That let us see now. So this is a statement: every square matrix satisfies its own characteristic equation. This is a statement of Cayley-Hamilton theorem. You know that characteristic equation is denoted by A minus lambda I, determinant of this equal to 0. This is the characteristic equation of a given matrix. It satisfies the given matrix, means in place of the lambda, after finding the eigenvalues, characteristic equation, just in place of lambda if you substitute, it must satisfy. So using Cayley-Hamilton theorem we can find the power of a matrix, we can find the inverse of a matrix, right? Now here in this lecture we are going to see how to find the inverse of this matrix by using Cayley-Hamilton theorem. So let us see one example. A is equal to 3 1 1 minus 1 5 minus 1 1 minus 1 5. This is a 3 by 3 matrix. So obviously we have 3 eigenvalues. We don't bother about finding eigenvalues, just we have to find the characteristic equation. To apply the characteristic equation, first determine the characteristic polynomial of the matrix, which is denoted by rho of t. And how to find the characteristic polynomial? This is the characteristic polynomial A minus lambda I or A minus ti. If you equate this A minus ti to 0, this is called characteristic equation, and this is a characteristic matrix, right? Among all the diagonal elements given in the matrix, you subtract t. So 3 minus t, 5 minus t, 5 minus t, remaining all elements same. You know how to find the determinant of a 3 by 3 matrix. Expand this. So 3 minus t into this minus this into this, minus 1 into 5 minus t, minus 1 into 1. So on simplifying this determinant, we get the characteristic polynomial, which is a third degree polynomial. Since we have 3 by 3 matrix, obviously we will be getting the maximum of third degree polynomial. So this is a characteristic polynomial which is given by minus t cube plus 13t square minus 54t plus 72. Now by the statement of Cayley-Hamilton theorem, this characteristic polynomial must satisfy the given matrix. If I equate this to 0, I get this is equal to 0. So every square matrix satisfies its own characteristic equation. So this is the characteristic equation, and since it satisfies its own equation, just replace, in place of t, replace a. So minus a cube plus 13 into, just in place of t write down a, minus 54a plus 72 is a constant, that's why write 72 id, identity matrix I. So just writing this matrix here, 72i is equal to this. Take this a to this side, we get A inverse matrix, that is 1 by 72 I into this matrix. So to find the inverse of matrix, I have to find the A square value, multiply A with 13 and multiply the identity matrix 54, and solve this, we get the required inverse of a matrix. Now let us see. A square means A into A, multiply the matrix 2 times, so you get this matrix. I hope all of you know how to find multiplication of 2 matrices, right? So next 13A, just multiply the matrix A with 13, so 13 into 3 39, 13 into 1 13 into 1, 13 into minus 1, 13 5 65, 13 into minus 1. So multiply each and every element of A by 13. Next, in this equation we got 54i. I is identity matrix 3 by 3 matrix 1 0 0 0 1 0 0 0 1. Now I want 54i. So multiply each and every element with 54. So we get 54 0 0 0 54 0 0 0 54. Substitute all these matrix in this equation. So we get A inverse, which is 0.0139 into A square minus 13a plus 54i. Here what is the A square matrix? 977. This is 977 minus 9 25 minus 9 25 minus 11. Next 9 minus 9 27, 9 minus 9 27. This is A square minus 13a value 39 13 13 minus 13 65 minus 13 13 minus 13 65 plus 54i plus 54 0 0 0 54 0 0 0 54, and total you multiply with this value, right? So 9 minus 39 plus 54. So 54 plus 9 is 63 minus 39 is 24. Like that you subtract this matrix into this and add this matrix, you get this matrix. You multiplied with 0.0139 by each and every element, we get the required matrix inverse. So this is how we find the inverse of a matrix by Cayley-Hamilton theorem. Suppose for the same matrix, if you want to find if you want to verify the Cayley-Hamilton theorem, verify means whatever the characteristic equation we got here, just we need to find the values of a cube, 13a square, 54a and 72i. This is one matrix, this is another matrix, this is another matrix, this is another matrix. Find all these matrices, substitute in this, we get null matrix 0 0 0 0 0. Then we say that this matrix is verified. Cayley-Hamilton theorem is verified. This verification can be done by substituting these values here. After finding the characteristic equation, just replace t with a, find the values of a cube, a square and whatever the values are there in the characteristic equation, substitute in that, it must satisfy. Then we say that Cayley-Hamilton theorem is verified. And also we can find the power of a matrix. Say for example, if you want to find a power 4 or a power 6 or a power 8, that can also be done by using Cayley-Hamilton theorem. That we'll see in the next class. Thank you.